Okay, Geometry AB, last week we started section 11.2, which was on surface area of prisms and cylinders, and we really just walked through the examples that dealt with prisms, but today, for what is now part 3 of our notes, we're going to dive in and start doing cylinders. So let's jump down here to number 5 right here. Alright, the formula for surface area of a cylinder looks totally different than what it was that we were doing last week, but if we look a little bit more closely, we see that it's really the same formula. What we wrote down last week was surface area of a prism was going to equal 2 times capital B, that was 2 times the area of your base, plus the perimeter of your base, multiplied by the height of that prism. And the formula right above that we just wrote down here for surface area of a cylinder, well, actually has a lot in common with that. In a prism, we used a capital B to represent the area of our base. Well, in a cylinder, your base is always going to be the same shape. It's always going to be a circle, and if we broke a cylinder down flat, this is what it would look like. And this circle down here on the bottom would be the base of that figure. So the area of the circular base is always going to be given to us by the pi r squared that we see right there within that formula. So this capital B in a prism now became more specific, a pi r squared within a cylinder. The capital P that we talked about in a prism stood for perimeter of the base. Well, the perimeter of the base in this case here, we'd be talking about the distance around this circle here on the bottom, and the distance around a circle is called circumference. And if you recall this formula, the circumference of a circle, this was in chapter 10, is 2 times pi times the radius. So this perimeter of the base here now became the circumference of a circle, 2 times pi times r, and the height of the prism is exactly the same as the height of the cylinder. So this formula right here for surface area of a cylinder looks complicated. It's one that if we were taking a test or a quiz on, we would give that to you guys or let you write it down on a note card, but that's our formula for surface area of a cylinder. The 2 pi r squared at the beginning takes care of this circle on top and this circle down here on bottom, and then the second term, the 2 pi rh, really gives you what's called the lateral area. It's basically this one big rectangle here in the middle, and if you've ever peeled the label off of a soup can and then laid it out flat, you're going to remember that that shape is in fact a rectangle. So that's what we need, and now that we have that one formula down, most of these problems should be okay. So let's take a look at what's going on right here. We have ourselves kind of a short, wide cylinder. I always imagine this is kind of like what a hockey puck looks like, or maybe a can of tuna that you pick up at the grocery store. So let's write down our formula here. Surface area of a cylinder is equal to 2 pi r squared plus a 2 pi r h. So, in looking at that, it looks like we need to know the radius of our cylinder. There's the radius showing up again, and we need to know the height. And other than that, we should be good to go. So let's fill in what we know in step 2. Surface area is 2 times pi. Now, in terms of the radius of this thing, the radius, remember, is a segment that goes from the center of a circle out here to the side itself. That's r. Well, down here on the bottom, this entire piece coming across was given to us as 24 millimeters. That is our diameter, the distance always across, and the radius is always going to be half of that diameter, so the half of 24 is going to get us 12 millimeters for the radius of this figure. So 12 is our radius, and we're going to square that. And we're going to add to that now. Here we go. 2 times pi. The radius here is exactly the same as the radius was just a second ago. That's still going to be 12. And the one tricky part about this problem, they did not give us the height. The height of a three-dimensional solid is defined as the distance between its bases. So if the bases here are the circles on the bottom and the top, this piece perpendicular to it is going to be the height. All right, so to figure that out, we're just going to take a look at the fact that the height right here, the diameter of 24 on the bottom, and then this diagonal of the cylinder that they've given us right here are going to form a right triangle. We know that we've got a perpendicular set of line segments right there. So we can use the Pythagorean theorem in order to figure that out. So I'm going to do this on a separate page here. We had a leg of h, so it'd be h squared plus 24 squared was equal to our hypotenuse squared. So that's going to be a 25 squared. And I'm doing this by in my head, everybody, but I think I got this one down. The 24 squared, I believe, is going to get us a 576. The 25 squared is going to be a 625. We're going to subtract that 576 from each side here. And we're going to get h squared is equal to, and that should be a 49. We'll take the square root of the left and the square root of the right and get that h is equal to 7. Okay, so back to this problem over here. We now know that our height is going to be 7 millimeters in this figure, so that is what's going to go right there. Okay, and this number is going to get pretty big here. Remember, everybody, that we're going to try to do as much of this as we can and keep it exact rather than trying to round answers. So if you're going to do the 2 times the 12 squared, you just got to be careful to remember order of operations there. The 12 squared happens first, which is a 144, times the 2 is a 288, and the pi just tags along for the ride. Adding this over here, the order you multiply this in doesn't really matter. The 12 times 7 is 84. 84 times 2 is going to be a 168 pi. And now we have 2 like terms here. They both have a common factor of pi, so we can go and add the 2 of those together. And that looks like it is going to be 356 pi, if I'm not mistaken. Linear units here were given to us as millimeters. So the area for surface area is going to be square millimeters. So 356 pi is going to be our answer for example A. All right, and there was our Pythagorean theorem work. Let's look at one last example before we're done with this one. And it's a little bit wordy, but they're telling you here a cylinder has a radius of 7, and they tell you the surface area of this thing is 189 pi square inches, and we are supposed to come up with the height of this particular figure. So these are the types of problems that give people fits the first time that they see them. So we just got to remind everybody that the formula is kind of the roadmap for laying all of this out. So always, 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 step 1 is to start with your formula. Surface area of a cylinder is going to be 2 pi r squared plus 2 pi r h. Just like before. Now step 2, fill in what you know. The only difference now being that in this case, and this is unusual, the less common case, we actually know the surface area. The surface area right here was 189 pi. So that's something that we know. And that equals 2 times pi. For the radius, they told us the radius here was 7. So we're going to put a 7 there for r and square that. Plus a 2 times another pi. The radius again is still 7, and the one thing that they didn't tell us right here, the one thing we're supposed to find, is the height in this figure. So we're just going to leave the height as an h. We're not supposed to know what it is right now. That's what we're trying to find. Okay, before we go any further, we've got a little bit of simplification to do here and a little bit to do right here. So 189 pi is going to equal, all right, the 7 squared is 49. 49 times 2 is going to give us a 98 pi, plus the 2 times the 7 is a 14 pi, and the h is still just tagging along here. All right, from there, everybody, we now have 3 terms in this equation, 1 on the left and 2 on the right. This is the one right here, the variable that we're looking for. So we want to isolate this term by subtracting that 98 pi from each side. Okay, so let's see where that's going to get us then. A 189 pi minus a 98 pi, I believe, is going to give us a 91 pi here on the left. Those 2 terms are gone, and we're left with a 14 pi times h. Okay, and from here, we're trying to get h by itself, and if we look at what's happening, the h is being multiplied by this 14 pi right here. So we're going to go ahead and divide the right side by 14 pi and the left side by 14 pi as well. Now I've got to warn you guys, if you're using your calculator right here, especially if you're using an older calculator or the one on your phone, it's really easy to get this problem wrong. What you're going to need to make sure that you do is put parentheses around that 14 pi that you're divided by. Okay, if you don't do parentheses and you just type in 91 pi divided by 14 pi, you're going to get an answer that's way off from where it should be. Really, the better thing to realize is that there's a pi on the top and a pi on the bottom that just automatically wipe each other out. Of course, that same thing happens over here as well. But when we do that, everybody, that 91 divided by 14 gives us a nice clean answer right here of 7. Units for area were square inches, and when we take the square root of those square inches right there, height is a linear measurement, we're going to end up with just 7 inches now for the height of that cylinder. And that's a wrap then, everybody, on Chapter 11, Section 2.